The next area of new capability in Oracle REST Data Services 3.0 release that I'll cover is security. ORDS supports OAuth 2 security standard, which is a standard that was defined by a number of vendors. It's oriented towards the internet, HTTP, REST, cloud deployments. Supported by Microsoft, by Google, by Facebook, by Oracle. What is new in 3.0 is that the support is more comprehensive than before. So OAuth 2 support came out in previous releases that is more comprehensive in 3.0. In particular, there is a use case called client credentials, which is suitable for most enterprise deployments of applications that I'll be covering a little bit later. But it will, there's also a number of other smaller improvements and refinements and better user interfaces and screens and that sort of thing as well. So OAuth 2 is, the good thing about OAuth 2 is that it supports a very broad range of clients. It supports conventional app servers. It also supports applications deployed in browsers, in JavaScript, or native mobile applications as well. It supports both conventional commercial applications and new consumer-oriented delegated access applications. I'll be covering both those use cases in the next couple slides. Fundamentally, it uses a token passing mechanism over SSL. So after you go through all these flows, authentication processes, the end result is you get an access code that is passed in HTTP calls. In some scenarios, you have a refresh token that can be used to refresh the access code, but fundamentally it's an access token passing mechanism. ORDS implementation of OAuth 2 uses other authentication and authorization capabilities that are in products that are like WebLogic, Tomcat, or Application Express. It doesn't have its own authentication and authorization capability, or at least not a sophisticated one. There's no point in doing that since those are readily available by other very mature and well-developed middleware products. So the two scenarios, use cases I'll be going through is first is one oriented towards conventional commercial applications. This is called the client credentials flow. And the way it works is very similar to the way enterprise applications have worked with database in terms of security for a long time now. So the way it works is that an authorized administrator registers the application server, the application that runs in the application server with the resource server using ORDS. Then the application then connects and authenticates itself and receives an access token, which it uses for to authorize subsequent HTTP calls. It also receives a refresh token because applications servers can store secrets like the refresh token in a secure way, because application servers can be locked down, secure environments. And then uses the refresh token to get new access tokens at frequent intervals. The other scenario is a very interesting one. It's more complicated. It's many steps to the flow, but essentially it's a very easy, pretty simple kind of concept. Instead of having two entities, we have three in this case. In fact, the full name in the OAuth 2 security standard is third-party, three-legged authorization code flow, which is quite a mouthful. But again, the way it works, it's basically a pretty simple thing. So there's three entities. There's a user. The user has data in a resource server or a database, which uses ORDS to provide REST access to it. And what we want to have happen here is we want to have the user be able to authorize access to that data by a client application, but not full access to that data. It's more restricted access to the data. So the client may only be able to access a subset of the data, or may only be able to perform a subset of operations on that data. It's analogous to a valet key. So if you park your car with a valet, if you have a valet key, you can give him or her that key, and they can start the car and drive it and park it, but they can't use the key to get into the trunk. So if you have valuables in the trunk, those valuables are secure. So it's restricted abilities is what you get. And the key thing to understand about the authorization code flow is that, and the really essential thing is that the client application never gets access to the authentication information for the user. So they never see the user entering a username and password. So there's no security exposure there. The way it works in a nutshell, in a simplified form, is that there is an authorized administrator who registers the client application with the resource server using ORDS. This provides a channel of communication so the client application and the resource server can communicate with each other. The user who is using the client application then wants to authorize the client application to access this subset of data and capability in the resource server. So what the client application does is passes the user to the resource server or to the ORDS mechanism being used by the resource server for this support for OAuth 2 security. The user then authenticates him or herself with a username and password and explicitly authorizes the client application to get this restricted access. The resource server then communicates with the client application, and key thing, giving the client application an access code and in some cases a refresh code, refresh token, to be able to then have a connection, a secure connection from the client application to the resource server to be able to perform the operations and get at the data, restricted access to the data that the user has just authorized. So this is a very interesting kind of application, and we look forward to working with users who are going to be trying out this. Okay, thank you.